Hey guys, so thank you for joining to May. We're in May. Days are getting hard to remember now, and even months. So this is our May meetup for Kubernetes and Cloud Native Louisville. We have Jeremy Tate up there, but it's not Jeremy, it's CJ. CJ is going to be talking to us today about migrating from AWS Elastic Beanstalk to EKS, and see if we got any updates. I think it was a little sparse from last month. I think the only thing I saw that was interest to update everybody on was Helm graduated, so it's a graduated project now. And I think had Vitas 6 was released. Anybody else see any other updates from the CNCF or any of the projects that they want to talk about, or they have any other project updates that they want to discuss? No? All right, well, we can get right into it. So, CJ, I'll go ahead and hand it off to you, and you know, let's watch this update go through. I'm excited about this. We've been talking about it for about a week now.
Yeah. Alrighty. So I get started. This presentation, I would say, is going to be like a 1 to a 200 level type of talk. It's not going to go in depth of Kubernetes. So if you're looking for that, bear with me. I'm going to be talking through a few other tools. We're taking an existing Java application that runs on Elastic Beanstalk, and we're curious about containers. And imagine a shop that isn't doing any sort of engagement with somebody like Contino. A shop that is self-managed and maybe just kind of bogged down with the typical day-to-day work, doesn't really have time to go and explore, experiment, and really consider other compute platforms. So that's kind of the context this is coming from. And so imagine that you've devised a gradual experiment, trying to kind of create that path to get more folks to go down it, to experiment with these other compute platforms and consider them for adoption. So you've created that path, and you're starting to turn away to help make that path happen. So that's our scenario. And with that, our goal today is going to be doing a little experimentation with three of the main compute platforms here, Elastic Beanstalk, starting with the baseline configuration of a Java SE platform, and then taking a gradual step, just wrapping that existing Java app in Docker, and then using Beanstalk on Docker, and then throwing that over to ECS Fargate, going from one extreme to the other to be fully managed, and try to go serverless with it, and then kind of meeting ourselves in the middle with EKS, running our app inside some pods. So that all sounds good and seems like a lot of playing around with toys, but why though? What's the thing that we're going after? So a few of them are, quicker scale and deploy times with Kubernetes and containers. You're not have to pay the tax of the overall base operating system getting up and running and provisioning that infrastructure. You can remove some of that unless you're having some scaling events that have to go horizontal, but a lot of that can be mitigated as well. So that the potential of operators, custom operators, and being able to write prepackaged things that would self-discover and provision your apps end to end, and kind of build your own kind of catalog of just drop-in experiences for a development team. You can do that with many other tools and in many other ways, but Kubernetes offers an entry point into doing that as well. And then our third point here is trying to enable our dev teams to manage their application infrastructure in languages of their choice. That's where we're actually going to be doing some stuff in CDK today, just to kind of see what that's like. And I looked around. James even said it. Not many are using CDK, it seems, outside of Amazon itself. So maybe it's just up and coming, but I chose to take it on and figure out a few things here for us today. And then the last one, which is mostly the important one, is if there's any opportunity to reduce our total cost, like our total cost of ownership for our existing solution. Maybe what we're doing today doesn't make sense, Maybe we reorganized and don't have a central team around ops, or want to go to more managed services. So that's kind of the why getting into this. No real big surprises there. So just a survey of the tools that we're going to be seeing a little bit today. CDK and CDKs. CDK allows you to code in other languages. That kind of compiles down to CloudFormation and is deployed out via CloudFormation. The big benefit is that it gives you a type system, just what TypeScript does for JavaScript, but for your CloudFormation. And it has its ups and downs. It has a few rough edges that can probably be smoothed out, but overall, I would say it was a good experience for this experiment. CDKs, you could equate it somewhat to Helm a little bit, and you'll see that a little bit towards the end. And then all of our other AWS services that we're going to be plugging in today, CodeBuild to get some of the stuff for Elastic Beanstalk, and then all the way down to EKS. If you haven't noticed already, link to the slides with all the information and the code there. So starting off with our baseline. Our baseline application is a Java 8 app. I hijacked an AWS sample app, and it's the EB Java Scorekeep, just an app that does a little game of tic-tac-toe. And you see here in the diagram that, generally speaking, we're going to have our customer traffic going to Beanstalk, and our engineers are going to submit some CloudFormation, and then it'll create their platform of type Java on Beanstalk to run the app. So that's kind of our base case. So I'm going to switch over real quick. And here, I've already got the pipeline and everything wired up with this one and our next one kind of already pre-configured. But you'll see here that we've got our typical source, build, and deploy all the way to Beanstalk. And if we want to go check that out, we can go to our Java 8 one, go as URL, and see here we've got our little app running over on Beanstalk. So that's kind of our baseline. A good next step, a quick follow-up, is reusing essentially the same pipeline to put in parallel stages these experiments. Oftentimes working on experiments, you see ad hoc things glued on off to the side, but here we can start doing gradual improvement and refactors of those processes. And that's where I've already put in step 2, where we've got our Docker, same repo, we're just building it a different way and then deploying it over to Elastic Beanstalk for Docker. So here we have that app here running. So taking a step back, to dig in a little bit into what this looks like. In the docs here that I've drafted up, I've got a lot of this kind of abstracted away through a lot of makefile stuff. But over for the Beanstalk app, we've got our build specs that do all the Docker type things that pump out the Docker run necessary for Beanstalk Docker to then deploy it. And then over here with our simple Java one, and then a slew of CloudFormation. This is for both stacks. I didn't parameterize much, and so it was all kind of put in the same place. But you see a lot of code here, and we probably all kind of been there if you've been managing workloads inside of Amazon. CloudFormation is rather verbose. You can go to nested stacks and such to minimize that, but it really you're going through a turn of making your changes here, doing your AWS CloudFormation validate command, and then pushing it up and see if it has a runtime failure. That kind of feedback loop is shortened a little bit in some of our next stages that we're going to get to. So back to our presentation here. That's our baseline in our first experiment kind of covered, where we take that existing app, we package it up as Docker, and then supply it over to Beanstalk and ship it there. So no real major surprises, just like a gradual step, an in-place upgrade or modification to kind of experiment with Docker, say that the department has no clue what Docker is. That's a really low barrier of entry to get that looped in there. And then the benefit of that is we've already been, exfiltrating that to ECR, and that opens the door for us to do things like Fargate. Once we have it in ECR, we then can go from there and codify it to whatever other compute target that we want. So in this case, Fargate. So this is where introducing CDK, a different way to codify your infrastructure. And in this case, using CDK to actually create the ECS cluster, and then CDK to create the Fargate service, and then ship it to ECR. So a couple of highlights there. Switching over, you'll find in these directories I've got them broken out as infra, CDK, and CDK8s where possible. And in this case, to create our cluster, our ECS cluster is this. Below this line is actually wiring up everything else. So some of the benefit here, I originally was writing, artisanal CloudFormation for all of this, and it can be rather cumbersome to have to wire that up and follow best practices. So in this case, after looking around, I found CDK and plugged it in, and it generates you some of the common constructs, and they even have this ECS patterns that we're using below that gives you the ability to prepackage a lot of this and use with best practices already embedded. So this alone generates our full cluster, wires it up to that VPC, and then below you'll see, here's where we're going through and actually creating the Fargate service from 2 different Docker files. And this is a really cool part that I found to be really, really handy. That the image reference here inside of the CDK for this can reference from a local file path. And whenever you actually run the commands to deploy CDK deploy those templates out, it defers that and actually will build it and push it to ECR and then replace this here with the image URI. And the same here. So we don't know of any specific ARN or otherwise to the fully qualified, ECR repository. Instead, you get the benefit of just kind of relatively pathing to it. And if you were to put this in a pipeline right next to our existing one, unfortunately, I didn't get to that stage, but I would be putting this right here, and part of the deploy would be a CodeBuild stage right here, taking care of my CDK-based deployment to my cluster. So now we're kind of already through the most of our third experiment. You'll notice being able to add, manage policies, and then all the way to outputting our DNS, our load balancer DNS. So going over here, scrolling up a little bit, my Fargate cluster is actually in a bad way from some stuff I was doing right before demo. Tempting the demo gods. I didn't do a sacrifice beforehand, but you'll see that at one point we were able to successfully deploy with no changes. Up here, I removed our service, our Fargate service, and then was working on rolling it back out further down here. And that's where it got a little dicey, but something I'll polish out once I go to open source all of what was done here. So back to our presentation, this is our kind of second experiment of, now we've got our Java app in a container over to Fargate and deployed over there. What do we want to do? Do we want to keep testing it internally? Do we want to cut it over for customer traffic? We've got a few options, but we never tore down our old infrastructure, so we're still in a really, really nice place as we're investigating if we want to go further with these efforts. So moving on to EKS, really closer to the point of our group here is this one. So here we've got the same pattern, CDK configuring an EKS cluster, and then CDK deploying Kubernetes resources. So rather than using Helm or just straight on Kubernetes manifest, leveraging CDK to do some of that. So we'll switch over to what that looks like. Here is an example of our cluster. This is a full 2-node cluster, M5 large on our VPC, handles the master role and all the stuff behind the scenes for the networking. This turns out to be quite a significant amount of cloud formation that gets generated based off of all of that. I've not gone through fully to investigate every bit of what's generated here. They say these are often best practices, but looking at what's generated definitely could be a little weary of cost associated. Maybe there's a different way to solve some of this, but really to be able to generate this much infrastructure off of so little, that's 1,200 plus lines of cloud formation, JSON of course, but even still, a lot of this configuration is rather mundane to churn out by hand. Another alternative, using something like EKS, the CTL, and bootstrapping your clusters that way. But here, as someone coming from a primarily development background, this was refreshing, being able to declare this out, get that out there, and get it shipped. So moving over to my tab here for the EKS one, you'll see right at the finish line before our meetup, I was able to spin up another one of these clusters for us to mess around with. So what we're going to do here is actually I'm going to go ahead and copy this command here to bootstrap my kube config locally. And I'll check to see what all is out there. And we see that's pretty much nothing, just our base cluster out there and running. And our next step is that we can actually start sprinkling in our little service. So I left this on, commented out so that we could kind of see what that looks like and roll out our service here to our Kubernetes cluster. So first up, we're making our image asset from our relative path to our app. Got this helper method here that I borrowed from another repository that I'll reference here in a little bit. But this helper generates a lot of the manifest necessary, and then I'm using it to just allow me to supply environment type information. The application, as it sat already, leverage these environment variables rather than trying to refactor an existing app, trying to sideload and shim this around just so that we can get this out there and trying things out in practical. So that's what it looks like behind the scenes in this. You'll probably see some familiar things here, setting up our deployment and our load balancer. So moving along, we then are using those to create our resource, and then also creating a little front-end app, for Nginx to reverse proxy our application. So imagine that I got here, I had my cluster, I just wrote this code, and I want to go out and deploy that. So in this case, we're inferring a number of variables there that are passed in that we're referencing. This is where that relative path to that image asset is doing the build and publish from our local machine. If we were doing this from CodeBuild, we would just grant the CodeBuild access to do all these operations. It would do that there, and it would take care of kind of its own ECR repository at that point. So while that's running, I'm going to go back over to our CloudFormation console, and we'll see that here our cluster is actually upgrading or updating right now. It's actually handling these custom resources. Behind the scenes, CDK is using some bootstrapping to the AWS account to create custom resources, do stuff with the serverless repository in Amazon to go through and template those things out. Think CloudFormation macros, but for these manifests. So back to our command, you'll see that it's getting to that point. We're at 2 of 10 steps. We should see this roll out in just a matter of minutes. So while that's running, I'll switch back over to our presentation and talk a little bit about what's going on. So we've just checked that in. We've already created our cluster, and we're at this stage right here where we've codified our Kubernetes resources, and we've pushed those up, and right now it's rolling out. So I'll actually open something up. Let me go and open another terminal, and let's see, what's the command for that one? So we'll see that right now, we caught it just right in the nick of time there, but this is where it's starting to roll out. You know, say that we've set all this up in motion, and we're wanting to try out more of our applications and really get down to that granular, scale or deploy time speed. This would be probably where, as somebody that's actually not very informed on Kubernetes itself, that's trying to build a bridge to go do more investigation, this is where I think I would start looking to watch for those rollout times and kind of see where those errors would occur, and look for that overall cycle time for our big events, scaling, deployment, or otherwise. So at this point, that rollout took, let's see, 2 minutes, roughly, about 1 to 2 minutes to go through that path, writing code that we're maybe more familiar with as developers. And something you missed from not typing this in is, the autocomplete and such. You get all kinds of helpful tips and validations of errors from, oh, sorry, that, no argument needed there, or the wrong type being supplied in here. So let me say I, passed cluster in or something like that. I'm getting information saying that it is the wrong type.
Is that a VSCode plugin?
Yeah, this is actually a VSCode integrating with TypeScript. So it's TS-lint. That's kind of doing a lot of the heavy lifting, along with our feedback from TypeScript. So I maybe glossed over the benefits a little bit, but let me just say, for an example, since that got brought up, I'll just say a new repo. And at this point, you get a lot of information of the types, the expected inputs, and everything right here. And if I really have no clue and I'm not getting this kind of feedback at this level, I'll just navigate straight to that source, since it's dependency in our project here. I can dig in and go all the way in to find the information that I need to supply to satisfy this resource right here. So as a developer, this is a godsend, because maybe you don't have all the time to learn Kubernetes backwards and forwards. You really need to if you're going to be on the hook for supporting it. But if we're just at the initial phase and you're trying to onboard development teams into this level of exploration, this would be a great entry point.
Terraform's got some competition.
Yeah, they sure do. I was, as a few saw, Terraform was my original intent for codifying all of this. The more I looked into it, I saw an opportunity to play around with CDK and learn a few things there. And the state file, like in this case, we're Amazon native in this package scenario, but the benefits of Terraform are kind of outweighed by the benefits of CDK from my point of view, because you're not going to get that much feedback from Terraform. You're going to be doing a lot of planning, trying to find some of your issues there.
So from a developer's perspective, you would probably go with CDK.
From my experience here and from using Terraform, like I would use CDK over Terraform for stuff like this if I had the choice. If otherwise Terraform, you're
Terraform for like a base infrastructure, like setting up accounts and things like that.
Yeah, that's probably where I would use Terraform in a world like this. Use it for the base layer, the base kind of platform type of work, and then maybe try to give CDK an opportunity with the development teams because it supports all kinds of different languages. I was going to originally use Java for writing the infrastructure for this example since it was a Java app to kind of be like, you're a Java team, you know Java, you sell Java and Java accessories, but then you also need to learn a little bit about infrastructure or manage your infrastructure, so code in that. The actual reason I chose against that was because I did involve CDK Kates in this, which currently doesn't support Java. So I didn't want to make a little confusion there by having to suddenly switch a language.
Gotcha.
But yeah, so there we have it. We've deployed that out, and let's see if we can introspect on it a little bit more, maybe even connect to it. Last I remember, I had it working, but demo gods and all of that. So we've got our two apps here. Let me see if this one started up. So yep, we're all started. No runtime errors there. I'm going to say I probably jacked up some networking, so I'd be really surprised if this next one got working. What is it? Port forward. This app was running on 5,000 by default. So let's go and see. Yeah, I've got some configuration issues inside the app at this point, but the main benefit is that in a short putt, I've been able to get it over there, and now I can start digging through the, access issues or otherwise. I didn't really have to boil the ocean to consider what should my base infrastructure look like to try to experiment. So I could be going to town, adding more logging at this point to see if I could find where those errors were. Digging through CloudTrail and whatnot. So our last little wrap up here is what it looks like to separate out from CDK a little bit and use a newcomer. It's currently still in beta. CDK went GA, I think, within the past few months. And then CDK is newcomer. It is still in the beta phase, but it was targeted as being able to declare specifically your resources in a more terse manner as well, with the benefit that you get from CDK. So for what that looks like, we in CDK, this should actually say CDK does the cluster, and then CDK's deploying the Kubernetes resources. So going over to that, here's what that looks like. I did the basic hello Kubernetes at this point, and you'll see that it's just doing a chart. You have to import a few other things, and that's part of the initial setup. But this is what a developer would be experiencing rather than huge manifest files of YAML with no feedback. It looks very similar. You do get a little bit of feedback, and you can't, get around issues where you type in the wrong port number. I left a landmine here for myself. Yeah. So what's that look like to actually deploy it? Actually, just close that out. I think I put that one as EKS extra. So here we are. It does a compilation and actually then compiles it down to a Kubernetes manifest. So maybe you're already entrenched in Kubernetes and you've got your reservations against, reinventing the wheel or displacing one of your existing solutions for shipping out your apps. But in this case, it actually compiles, I guess we'd say transpiles or just formats down to actual valid manifests. And then you do use the Kubernetes kubectl to do the deployment. So if you're ever curious about what's going on under the covers, you see this. Now, you probably look at this and you're like, well, that's actually less lines than this. Yeah, that's fair. But I think some of the benefit is some of the syntax sugar and feedback that you enable for others without having to natively learn all of the nuances. So at that point, you'll see here that it did its deployment. And let me check my services. And we'll see here, we've got our infra CDK8 service that was up and running about 67 seconds ago. And let's see if it resolves. Nah, no luck.
Takes a few minutes for those clusters to come up, or for those load balancers.
Yeah, that's true. So here's us port forwarding into that app that got out there. But end to end, this was a pretty enjoyable experience. I knew nothing about what I'm showing you initially when I committed to this talk, so that was cool. But I'd say that this enables CDK and CDK8s are, I guess, the two main parts of this presentation that kind of organically came up as the more important things to kind of talk about while building this path is that we're trying to enable our engineering teams. There are tools like this available for consideration to help get them to adopt things. So with that, I leave you with all of this heap of makefiles to do all of these commands and do some of the local development as well. This was really trying to follow along with what was advocated at our presentation 2 months ago, the Three Musketeers methodology for makefiles, abstracting away all of that, rather than a bunch of bash. I was able to do some interesting stuff here with makefiles, so that was cool.
I like how you referenced our previous talk. Nice.
Always love a tie together, right?
Yeah.
So with that, that's about it. Any questions? Things we want to talk about?
Just force unmute everyone.
What are your thoughts on so you're using a SDK from Amazon? What are your thoughts on lock-in and sort of digging yourself into a hole, limiting flexibility later on? Either in the artifacts that you create themselves or in the experience that you're building up in this thing that you can't switch away from.
That is a very valid concern, and to help get to my answer on some of that is, where was it? So part of the artifacts that get generated, I think the lock-in is a necessary evil depending on your circumstance. I couldn't say it's a fair carte blanche answer to say, yes, do it, don't ask questions, or no, that's a bad idea. It kind of goes into one of those balancing, what do we need? And if our promise we don't know for certain that we're going to get there and land and stay in something like EKS or in these target compute platforms, then it doesn't matter. Minimize your investment up front so that you can lower your cycle time to make that investigation, get to the point where you get those answers, and then once you have those answers, reconsider if you stick with these vendor lock-in solutions or go with a more agnostic approach, be it just straight manifest, Helm, Terraform, otherwise. I would say it fits. I think it fits the problem here in this scenario that I kind of came up with, and that's convenient. But in reality, I would be hesitant about the vendor lock-in. But depends on your organization. Can you go to another vendor or not? Maybe you don't have the license in other places that enable you to operate with that other vendor or with in those different zones. I think it's a big question that you'd have to kind of see if it's a real problem or not. But it is a concern. Does that answer your question, Yukai?
Yeah, I think so. And one other thing, as you're speaking, I was thinking, if a project was going to move to another vendor, this could be potentially the smallest, difficult part of it. There's probably easy enough to convert it all and whatnot than other parts of a move. So, but yes.
Do you manage any of your resources like this with vendor agnostic solutions?
I'm still, for my own personal stuff, yes. I mean, I just use YAML files. Work-wise, I've only been there a couple weeks, so I'm not doing anything yet.
I mean, the way I look at it when someone asks me that question, because I get that question a lot as a consultant, is even if you use something vendor neutral like HashiCorp's Terraform, you still have to understand and reconfigure and code if you were going to try to do a migration, because the way you deploy an application on EKS would be different than you would deploy it onto AKS or any other Kubernetes managed service. So you still have to refactor and recode. So that's about one of the benefits you'd get if you'd use Terraform over using just CDK for everything. But it's also, like CJ said, what's your use case and what are you trying to accomplish?
Yeah.
Yeah, I mean, even with Terraform, right? You have lock-in, right? I mean, you're locked into an open source solution, but there's no guarantee of its support going forward. So, I mean, in similar ways, you're sort of locked into tooling that would require a lot of switching costs to go to something else.
I think if you go with the infrastructure as code approach and you're codifying everything, that will help. But yeah, you're still locked into a tool, to a process. So
I think one of the things, I mean, getting locked in, I mean, that makes sense. There's always some sort of commitment you're making to the tools you use. To me, it would be easier. I say this as I am 3 weeks into a new job, but I think these other tools would be easier. These skills would be easier to take to another job, to live longer in a career. I mean, if I've got a year with the CDK and all the job openings are listing Terraform, well, oops.
yeah.
So, but I mean, I think you're right. I think there's a lot of situations need to be evaluated individually on their own merits. And
yeah, I could say with the sorry.
Oh no, I'm done. You.
I can say with Terraform specifically, haven't implemented it for other admin tasks, non-Kubernetes related. The developer burden to learn a new language has always been a barrier of entry. Even though Terraform, once you've messed around with it a little bit and kind of understand the key concepts, you can be pretty pretty quick with it and pretty fluid with the workflow. But it seems like, in general, to those that are entrenched in their day-to-day product-driven application development, they just can't be bothered at times to pick up a new tool, a new language, be it configuration as code, infrastructure as code, HCL. It's not their language. It seems to always kind of be a huge, well, I'm paid to do this other thing, which can be tough. And that's where I got a little rose-colored glasses feeling with CDK of the underlying part that's driving it is this library, JSII, that from what I can tell is what does some of that translation, because CDK can be in all these different languages. It would just be the same as, rather than learning CloudFormation, you stick with your language and then just codify in your language your resources. If maybe down the line we see something like JSII become a little more agnostic to enable that for other platforms, similar to Terraform's approach with all the modules, that would be interesting to just kind of see what that looks like.
I think developers need to branch out.
They do that, man, every day.
They should, but I think there's a lot of truth to that. Like, this is my project. We're already behind. This shovel works. I don't need another shovel.
I don't need a backhoe.
Yeah.
No, that's great. CJ, this is awesome presentation, awesome demo. Thank you. Does anybody else have any other questions or comments for CJ?
Is there any tooling similar to CDK for Terraform, for generating Terraform in a similar fashion?
Yeah. My initial answer to that is writing your own providers in Terraform, and that is a deep trap, depending on if you're providing that to others. But if you're really looking to do a lot more for less in Terraform, that it comes down to making those experiences more ergonomic on the surface level in the provider that you provide yourself or others. I've not found personally, so I'm speaking to a little bit of ignorance. I didn't do too much of a survey there, but I haven't found anything that's like a higher level abstraction over Terraform itself. Terraform is the abstraction over HCL, it is the abstraction over all your underlying resources in HCL. So I would say your big option there is custom providers.
If you know Go. Oh wait, do they have to be written in Go? I don't remember if the provider has to be written in Go. I
believe it can be written in others, but I think Go is the best or the only one. Yeah, I think it's Go. I've written a couple of custom providers, and I only did Go. I don't remember ever seeing them be available in other languages.
Sorry, I'm reading the docs, and it doesn't have to be Golang.
It doesn't have to be?
No.
Really? Does it just have to match the schema?
What it's looking like. Anyway, with that, does anybody have any parting words of wisdom? I know I never do. All right, well, I will do my best to get this up tomorrow so that we have this for reference. CJ, I've already tweeted out the link to your presentation from your site. I'll get that posted to the meetup as well. If there's anything else that you'd like to provide, let me know. And with that, thanks everybody for coming. How's the 5:30 workout? I thought the 5:30 was a little bit better than waiting till 6.
Yeah, I think it was better.
Okay.
Worked for me.
Yeah, I know the noon might be a little tight for everyone because I know I don't always get to eat lunch at noon. So, all right. Thanks, guys. Have a nice night.
Thanks,
Bye.
Thanks
Thanks,
guys.
everyone.
CJ.
Thanks again, CJ.